The B-2 Spirit stands as one of the most iconic and technologically advanced stealth bombers ever conceived. Its radar cross-section is so small, enemy defenses barely know it's there. It can fly thousands of miles undetected, slip deep into enemy territory, and deliver a devastating strike before radar operators even realize what hit them. But the core question is, how does a bomber of this immense scale, 172 feet wide, achieve such profound invisibility to radar, and simultaneously carry the firepower necessary to neutralize entire target arrays in a single pass? Today, we'll thoroughly break down the engineering marvel that is the B-2 Spirit, exploring how this invisible force fundamentally redefined the landscape of modern aerial warfare. The B-2's remarkable story truly began shrouded in secrecy. During the late Cold War, US engineers faced a major challenge: how to deliver nuclear or precision strikes deep inside Soviet airspace, without ever being detected.
Let's try to increase the wingspan.
It should give us a higher lift-to-drag ratio.
Let's try it.
The solution they arrived at was incredibly bold. Not a faster plane, but a flying wing built entirely around stealth. This groundbreaking idea actually traces its roots back to Jack Northrop, a visionary engineer who experimented with flying wing aircraft as early as the 1940s. His prototype, the B-49, proved the concept, but it was too advanced for the technology of its time. By the 1980s, advances in radar science, materials, and computers finally caught up, and Northrop's dream returned, as the B-2 Spirit. Stepping inside the cockpit reveals an environment designed for intense, long-duration missions. Here, two highly trained Air Force pilots share the immense workload. In the left seat, we find the aircraft commander, responsible for critical mission decisions, all communications, and the overall flight control of this complex machine. To their right sits the mission pilot, meticulously managing navigation, vital fuel systems, and the advanced weapons deployment. Together, they continuously monitor a sophisticated suite of multifunction displays, providing real-time data on radar maps, weapons status, engine performance, and electronic warfare cues. Each pilot has an ejection seat. In emergencies, explosive panels on the canopy blow open, allowing rapid escape. During long missions, some lasting over 30 or even 40 hours, the two-person crew follow a strict alternating rest cycle. While one pilot remains fully alert, managing systems and communication, the other rotates into a short rest phase, reclining behind the seat in a small, darkened area built directly into the cockpit. There's no traditional bed, just a narrow pad, a blanket, and the steady hum of the jet's engines. They take turns stretching, eating pre-packed meals, and rehydrating through special in-flight rations designed for endurance missions. Even in rest mode, they wear headsets tuned to mission updates, ready to snap back to full control in seconds if something changes. The B-2's smooth flying wing shape scatters radar energy in every direction, keeping it hidden from detection. Every detail contributes to this. Even the smallest fasteners, seams, and panel lines are precisely designed to blend perfectly, preserving its critical radar invisibility. Without a tail or vertical fins, it relies on advanced fly-by-wire computers that constantly adjust tiny control surfaces to keep the aircraft stable, allowing precise flight where no human could manually hold it level. When radar waves hit the B-2's surface, most scatter away instead of returning to the antenna. Those that do reflect are absorbed by its composite skin, a mix of carbon graphite epoxy and ferrite materials that turn radar energy into tiny amounts of heat. Sensors automatically adjust the aircraft's attitude to minimize reflections at every angle. The result? A radar cross-section roughly the size of a small bird, making the B-2 one of the hardest aircraft to track on Earth. Building stealth at this level doesn't come cheap. Each B-2 cost about $2.1 billion, including research and maintenance infrastructure. Keeping one mission ready requires constant attention, and availability rates hover around 60%. But when commanders need a bomber that can reach anywhere on Earth undetected, cost becomes secondary. The B-2's true magic lies in its comprehensive avionics suite. A complex network of computers integrates the flight control system, weapons control modules, fuel management, navigation, and defensive electronics. Within the cockpit are systems such as the attitude display unit, radar display, multifunction control panels, and the mission management processor that synchronizes every sensor in real time. A unique feature is the pitot-static sensor plate that replaces traditional protruding pitot tubes. This flat plate measures airspeed and pressure without revealing radar reflective spikes. Data flows through redundant buses to 4 independent flight computers, ensuring the bomber remains controllable even if one system fails. Its communication suite allows encrypted satellite links and data sharing even during radio silence. Night or day, cloud or storm, the avionics enable precise navigation through the world's darkest skies. Hidden deep within the wing are 4 General Electric F118G E100 turbofan engines, each generating about 17,300 pounds of thrust. They're not mounted outside like regular bombers. They're built inside the wing to stay hidden from radar. The air intakes curve upward, keeping the spinning fan blades out of sight. Radar waves that hit these curves are scattered away, not reflected back. The exhaust passes through flat ducts across the upper wing, cooling the gases before they exit. And before the exhaust exits, it's mixed with surrounding air, dramatically reducing the aircraft's heat signature and making it almost invisible to infrared detection. This keeps the B-2 nearly invisible to enemy sensors. But this design makes engine maintenance harder. Since the engines are built inside the wing, ground crews need special tools and training to access them safely. Each inspection requires precision. One mistake could affect the bomber's stealth or engine performance during flight. How does the B-2 maintain flight control and aerodynamic stability without a vertical tail or rudders? On traditional bombers, the vertical tail and rudder provide directional stability and help the pilot control yaw, turning the aircraft left or right. They also prevent weather vaning, the tendency for the nose to turn into the wind. The horizontal tail, or elevators, handle pitch, keeping the nose level during climb, cruise, or landing. But the B-2 breaks this rule. Traditional bombers use tails and rudders. The B-2 doesn't. Instead, it relies on elevons, combined elevator and aileron surfaces, plus split drag rudders that open like clamshells at the wingtips. By adjusting thrust between engines, it can yaw left or right with minimal radar exposure. There are 4 pairs of control surfaces: outboard, mid, inboard elevons, and the split drag rudders. During takeoff and landing, the inner elevons manage precise control at low speeds, while the outer ones dominate high-speed flight. The quad-redundant fly-by-wire system automatically coordinates every surface, maintaining perfect balance and stability. When the pilot nudges the rudder pedal or stick, the computers translate that input into differential thrust and fine control surface movements. So the bomber turns left or right smoothly, while keeping its stealth shape intact. The B-2 carries all its weapons inside 2 internal bomb bays, a deliberate design to preserve stealth. When the crew opens the bay doors, rotary launchers quietly move each weapon into position and release them within seconds. It can deliver a wide range of munitions, from GPS-guided JDAMs to the B-83 nuclear bomb. Each bomb is mounted on precision lugs that keep it perfectly aligned within fractions of an inch. At the weapons facility, airmen prepare every bomb with care. They lift them from storage racks, secure them on transport lifts, and move them into the hangar. Each weapon is checked for serial numbers, fusing systems, and electronic readiness before loading. Then, using hydraulic lifts, technicians secure the bombs inside the bay, following strict alignment steps to maintain the aircraft's balance and stealth. Before any mission, the B-2 undergoes meticulous preparation. Technicians inspect the stealth coatings, known as radar-absorbent materials, for even the smallest scratch. A minor chip can reflect radar, compromising the mission. The aircraft is rolled into a climate-controlled hangar, where specialists apply new coatings layer by layer. Next comes systems testing, avionics calibration, hydraulic pressure checks, flight control surface tests, and power-on diagnostics. Ground crews verify engine start sequences and fuel distribution. This pre-flight routine ensures stealth capability, safety, and full operational readiness, a process that can take more than 12 hours. The B-2's internal fuel is stored across multiple composite tanks spread through the wings, forming part of the structure itself. It holds over 167,000 pounds of fuel. That's roughly 95,000 liters, or about 2.5 full-sized fuel tankers. This massive capacity gives it a range of more than 6,000 nautical miles without refueling. For global reach, it uses aerial refueling. In mid-air, a boom from a KC-135 or KC-46 tanker connects with a receptacle atop the B-2's spine. Fuel flows at thousands of pounds per minute, allowing the bomber to cross oceans without landing. On the ground, it can perform hot pit refueling, taking fuel while engines run, saving hours during rapid turnaround missions. Weighing over 160,000 pounds empty, the B-2 requires precision maintenance. During deep inspections, technicians position the bomber on massive hydraulic jacks, lifting it safely off its landing gear. This allows full access to wheels, brakes, and hydraulic cylinders. Every seal and line is checked for leaks, worn wheels are replaced, landing gear struts are repressurized. Simultaneously, engine maintenance crews inspect compressor blades and ducts for wear, using borescope cameras due to the engine's buried placement. Every maintenance step ensures reliability, because a stealth failure mid-mission isn't an option. The B-2 opened the door to a whole new era of stealth aviation. Its core design and technology now inspire the next generation, the B-21 Raider. The Raider builds on the B-2's stealth, but adds smarter digital systems, easier maintenance, and modern battlefield connectivity. Yet the original B-2 Spirit is still flying strong, and is expected to serve well into the 2030s. It proved that true invisibility doesn't come from magic, it comes from relentless engineering. The B-2 Spirit isn't just a machine, it's a symbol of what engineering perfection looks like. From its twin-pilot cockpit to its hidden bomb bay, from its ghost-like radar signature to its meticulously maintained skin, every detail exists for one purpose: survivability through perfection. Every detail tells a story of precision and secrecy. Which part stood out to you most? Like this video, subscribe, and join us at Corecraft Engineering, where we explain genius inventions and engineering that shape the future.